Hello students. Welcome back to the next class of the chemical dynamics. In the last class we have discussed about the ionic reactions and we have discussed about the double sphere model, and in the last class only we have discussed the free energy factor and the frequency factor. With change in charges on the participating ions, what will happen to the entropy, what will happen to the frequency factor, what would happen to the rate of the reaction, which we have already discussed in the last class. But now we will discuss the ionic reactions, but we will go with another model, and that model is generally called as the single sphere model. The single sphere model. Single sphere model. So what does this model says actually? In the double sphere model, what we said, ki there are two ions will be there, and the two ions will be approaching each other from the infinite distance to a, DAB distance, and in the activated complex the two ions will remain intact with each other. But although the two ions will remain intact to each other, the ions will not leave their identity. They will not lose their identity even if the activated complex will be formed. But in the single sphere model, what is happening here? The two ions are approaching from far away distance, that is infinite distance, and they will approach each other. And when they will approach very closer to each other, then they will form an activated complex. But a difference is there from the double sphere model is that whenever the two ions will approach each other which are spherical in shape, then when they will approach very closer to each other, they will form an activated structure, activated complex. But the activated complex is spherical in nature, which is formed by the combination of the two ions, but the charge on the activated complex will be the sum total of the charges of the ions which are approaching closer to each other. And this is all about the single sphere model. So we can write this is based upon the idea that two spheres merge into one single sphere with a charge equal to the algebraic sum of the charges on the ions. Therefore we can represent the model like this. Here it is a ion which is spherical in shape and has a radius of Ra, and charge on this particular ionic species is Za. And another sphere or another ionic species is there which is also spherical in shape according to this model and having a radius of Rb and charge of Zb, and they are mutually approaching each other from a infinite distance. They are just placed at infinite distance. So whenever they will approach each other, then they will form a activated complex will be forming. An activated complex is nothing but the combination of the two ions which are approaching closer to each other, and the charge on the activated complex will be the sum total of the charges on each ion. On each ion. Okay. So let us write a process. What is happening? Let us consider a process of charging a conducting sphere of radius r from an initial charge of 0 to final charge ZE. Actually, what is happening? So, what the model is saying about that whenever two charged particles are approaching each other, so another charged particle is forming due to the combination of these two charged particles. So until and unless they are they are not present closer to each other, the charged particle would have obviously zero charges because the ions are not combined. But when the charged particles are present in proximity with each other, in closer to each other, nearby to each other, then a charged particle is formed whose charge is equivalent to ZE. Therefore, it has been said that key sphere of radius r is formed and initial charge was 0. That means when the ions are present at very far away from each other, at infinite distance from each other, but slowly when they are coming closer to each other, then the sphere of interaction or the activated complex which will be forming, that will be due to the interaction of the two ions. So slowly that structure would have gained some charge, and when the ions are present very closer to each other or proximity of each other, then the activated complex would have a maximum charge, and that would have ZE, which we are saying just now. Okay, so now this is the process, and how this is achieved. This can be achieved by transporting from a infinite distance with small increment of charge equal to E d lambda, where lambda is the parameter that varies from 0 to Z. Okay. So the minimum charge a species can have, that is charge on an electron, that is equal to 1.6 into 10 to the power minus 19 coulomb. This is the minimum charge that a charged particle can have, and that is equivalent to E, which we have represented now. So now when the charged particles will approach each other, then slowly there will be formation of activated complex will be taking place. When they are present at infinite distance, the charged particle, we are thinking the thought process is like that, कि when they are present at infinite distance, this would have 0 multiplied by E charges, that means 0 charge. But when they will move further closer to each other, the charge on the activated complex will increase. 1E, 2E, 3E, same, just like that. And when they will present at close, most proximity of each other, the charge on the activated complex will be highest, and that would be the algebraic sum of the ions which are approaching. Therefore, E is remaining the same, but what is happening? A number is multiplying with E, and that number is nothing but the sum total of the charges of the ions which are approaching. Getting my point? So that number, this is a variation number, and that variation is here taken to be lambda. Understood? Okay. That is the lambda which we are talking about, and which varies from, initially it was 0 and that was moving to Z, and Z is the sum total of the charges of the ions which are forming the activated complex. Okay, so now you can write here, at any time charge on the sphere is lambda E. Okay, and if at a given instant the increment of charge is at a distance x from the ion, the force acting on it is, what is the force? What did I say? The two charged particles are approaching further distance from each other. Let us say the distance between the ions to be x, and the charges on each ion to be lambda E. Lambda would have some value, 1, 2, 3, something like that. So what would be the forces acting between them? F is equal to lambda E square divided by epsilon. Obviously dielectric constant will be there, x square. Okay, but you know that what is happening when the ions are approaching closer to each other, they are forming a activated complex, and the charge on the activated complex is the slowly getting increases, and that would become at last equivalent to the sum total of the charges of the ions. That means the charge on the activated complex is continuously varying when the x is varying. Therefore, the infinitesimal change in the force will take place, and that is equivalent to lambda e square d lambda. That means change in the charge is occurring, that's which is represented by d lambda, and this is your equation number 1. So we already know in the double sphere model that we are actually interested upon the work done on moving these ions from further distance to closer proximity. Therefore, we will calculate the work done. At last, we will calculate the free energy. Free energy is nothing but the maximum amount of work done that can be derived from a system. So, therefore, we will write that the work done by moving ions, obviously what is happening to the distance is decreasing. Ions from, if they are, let us say they are present at x distance, so infinitesimal change, they will move to closer to each other, that means the distance would decrease. Therefore we can write x to x minus dx distance. So what is the change in the work done would be? That will be equivalent to F into dW is equal to F, or small variation in the force acting between the ions and small change in the distance between them. That means x minus dx, that is equivalent to dx distance, change in distance, and df is nothing but lambda is square d lambda into dx divided by epsilon x square, and this is your work done, and this is the question number 2. So this is for an infinitesimal change, for a small change. But whenever we want to calculate the finite change for a process, we need to add all the infinitesimal change, and that is nothing but the integration. So therefore, if we will calculate the total work done of the system, and this is equivalent to the integration lambda is square d lambda dx by epsilon x square. But now the thing is that here there are two variation parameter. What are the two variation parameter? Here there is change in the charges. The closer the ions each other, the greater is the charges appears on the activated complex. Therefore, there is continuously variation in lambda. And also, as the ions are close, continuously moving closer to each other, there is also continuously variation in the value of x also. Therefore, during integration, we will use two integration values. One for the charges, variation in the charges, which is changing from 0 to z, and another the distance between the ions, which is changing from the ions were present at infinite distance, now they are moving to a closest distance, that is equivalent to req. Therefore we can take out the constant terms. What are the constant terms? The minimum amount of charge an ion can appear, that is E 1.6 into 10 to the power minus 19 coulomb, that is constant term. And as we consider the solvent to be continuous in nature, they are distributed evenly, they are distributed uniformly. Therefore, the property of solvent, that is a dielectric constant value, would have also similar value. Therefore, this would have constant value we can remove out from the integration. So this would have 0 to z, 0 to r, and the rest term lambda d lambda dx by x square. So this would give lambda d lambda, that means x dx. The integration of x dx is nothing but x to the power n plus 1 by n plus 1. That means x square by 2. So here instead of x is lambda, and we will use the upper limit minus lower limit, and we will again get back to the expression e square by epsilon, e square by epsilon, and here z square minus 0, that is 0, okay, and divided by 2. Okay. Next, x term, that is 1 by x square dx, that is x to the power minus 2 dx, that means x to the power n plus 1 by n plus 1. Okay, so that means this would have minus 2 plus 1, that means x to the power minus 1 divided by minus 1. Okay, I have left the negative sign here. Negative sign signifies the distance is decreasing between the ions, and this would be equivalent to the, we will put the upper limit minus lower limit, and at last we will come back to this expression like this, and multiplied by a negative sign, and that is equivalent to the z square by 2 epsilon r. This is the total work done. Total work done. And let us consider to be equation number 3. Okay. So now you already know that whatever the system a maximum work can do, that is equivalent to the free energy of the system. So we can write that this work is the electrostatic contribution to the free energy of the ion. Free energy of the ion, that is GEL, Z square E square by 2 epsilon R, and this is your equation number 4. So what is GEL? This is nothing but the change in electrostatic free energy. So now the question is that whenever the ions are coming closer to each other, there is a need to do work to bring the A ions also, and there is a consumption of work energy in the form of work to bring B also closer to A, or to form an activated complex. So there will be associated free energy with the A ion and also B ion, and also there will be associated free energy with respect to the activated complex which is formed there. So therefore we can write by using equation number 4 that GEL of A, free energy due to the A system or A ionic species, will be the charge on the A ion and the radius of the A ion. Similarly, GeLB can be given by the charge on the B ion divided by 2 epsilon RB, that is the radius of the B ion, and GeL aqueous, that is forming the activated complex that would have has some charge of sum total of the charges appearing on each ion respectively divided by 2 epsilon Req. So therefore we already know the total free energy of activation for one molecule can be given by dividing with the Na number, and this is the sum total of the free energy due to the electrostatics and free energy not due to the electrostatic. That means contributing, this is not containing the electrostatic contribution, but this contains the electrostatic contribution. Okay, so we can write down delta G non-electrostatics divided by N plus what is the total Gibbs free energy contributing to the electrostatic motion. This should be due to the ions which are approaching and the activated complex which is forming. That is 2E square by 2 epsilon divided by multiplied by ZA plus ZB whole square divided by Req. First term is due to the active free energy due to the activated complex. Next it is due to the free energy due to the A ion. Next this is due to the free energy due to the B ion. Okay, so now if we can write the free energy of activation only, this is nothing but by N plus N square by 2 epsilon and ZA plus ZB square by Req ZA square by RA minus of ZB square by RB. Okay, as we already know that from activated complex we have seen in the last class, also in the double sphere model we have seen the rate constant is nothing but the sum product of the frequency factor decomposition frequency, that is kBT by H, into the free energy of activation, Boltzmann factors, and we can write down kBT by H into e to the power delta G activation is equivalent to delta G net by RT into e to the power minus of N by 2 epsilon E square by RT all multiplied by ZA ZB square by Req minus of ZA square by RA minus of ZB square by RB. Okay, now taking ln both the sides, we get back to expression ln of k is equal to ln of, we are not separating, actually in the last class we have done like this only, we will not separate this, we will keep this this will be A and this will be B. Then after putting ln A into B, we will have ln A plus ln B. That means e to the power ln e to the power, like this term will be there. And ln e is nothing but 1. That means at last your expression will be 2 epsilon, and r is nothing but Na Avogadro's number into Kb. Here Avogadro's number, it is also Avogadro's number, that get cancelled out. Therefore, the expression will be Kbt whole into Za plus Zb square divided by Req minus of Za square by Ra minus of Zb square by Rb. This is the final expression. What is the equation number? Would be, this is the equation number 5. Okay. And just in the last class which we have plotted in the double sphere model, we can also plot here also. Here we can write down this is a constant term. Let us say this to be k naught and minus of square by 2 epsilon kbt za plus zb square by req minus of z square by ra minus of zb square by rb. This is your question number 6, and this is your logarithm of rate constant. And this expression is actually talks about the rate constant of ionic reactions, which relates with the dielectric constant, the temperature of the reaction, and also the charges appearing on the ions and the activated complex forming. So this is an important expression to understood how the ionic reactions are occurring in the reaction medium when the reactions are occurring in solvent. So if you change the solvent, the dielectric constant value will change, and what would happen to the rate constant, what would happen to the reaction rate. This expression is beautifully explaining the things. So in the next class we will learn some of the consequences of double sphere model and single sphere model. What are the different aspects which these two models can able to explain for the ionic reactions which are occurring in a reaction in the presence of the solvent. Okay, so for this class this much only. We will meet in the next class soon. Thank you so much.